Thank you. Let me start with a quick agenda. We're going to do an introduction. I'm going to introduce myself quickly. I'm going to talk a little bit about what we're doing with Firecracker. Although I think most people have watched the talk, so I won't duplicate that. And then I'll go through the pre-submitted questions, and then we'll have about half an hour to do 20 minutes, half an hour to do live Q&A. Great. So yeah, I'm Mark Brooker. I'm a senior principal engineer here at AWS. I've been at AWS since 2008, working on a wide variety of things. I started off on EC2. I worked on storage for a while with EBS. I worked on some of our IoT products for a while, and then since then my focus has been on serverless. Starting with Lambda, and more recently, I've been focusing more in our database space. I joined AWS after grad school. And did something completely different. I was doing radar signal processing before this, so very big change of direction for me. Cool. So AWS Lambda, as you all know because you've watched the video, is our serverless compute, or one of our serverless compute offerings. At AWS, Lambda and our serverless container offering Fargate are both based on this lightweight virtualization technology called Firecracker. We released Firecracker as open source in 2008, and are building an increasing number of systems and services and offerings with both Firecracker and the components behind Firecracker, which are slowly sort of getting separated out into Rust VMM as a collaboration between AWS and the open source community. And always thrilled to have a great community around open source projects. So let's dive into the questions. So the first question is kind of actually a bit of a statement. I guess that's fitting for a conference. From Indiana University. We would love to connect, with specific people working in this area. If you're doing research in serverless, reach out to that email address that Darby shared with us. Great to hear that you've been working on Spot, and I think there's, this is just such a fascinating area to be working in both research and industry at the moment. I'm just super excited about serverless. The second question: given the cold start cost, how do you decide when it makes sense to spin up and initialize a new micro VM, and when is it better to queue function invocations? Yeah, so that's really interesting. We use a whole bunch of signals for that. One of them is obviously concurrency, and the history of concurrency. And so, we think that in-system concurrency is a better measure than arrival rate for most kinds of scaling decisions. We look at queue depth. We look at the history of queue depth. And queue depth specifically in time, right? Like how long is it going to take to drain a queue? We think about prediction. We've done some interesting work on around, that we haven't published around, using techniques like reinforcement learning to predict the future of incoming invocations. But ultimately, I can't really answer this question because the details here are secret source. They're internal details to AWS, and the reason for that is because getting this right, like this is one of the core problems of doing serverless economically, because there's a cost to spinning up, and there's a cost to running, and there's a cost to delaying. And if you don't want to overshoot, but you also want to, you want to scale up fast enough to give that to meet the instant scale experience that customers expect of serverless. and finding the right balance between those and finding the right signals for that is a super interesting problem, and it's one of the things that my teams focus on. Most actively. One of our sort of top kind of development and research areas. Do you see the interesting scheduling challenges for serverless functions? So I think there are two interesting angles here. One of them is the in the large scheduling problem of do I spin up more? Which box do I send this to? Where do I send this work? And then the other is an in the small scheduling problem of I have hundreds or thousands of tasks running on a single machine. How do which one gets CPU time? And this is the kind of really classic kind of OS scheduling problem. And that's an interesting problem in the serverless world too, because it's so deeply multi-tenant, because we care about tail latency a whole lot, because some workloads care about throughput a whole lot, and so there's really interesting kind of on-machine scheduling challenges of who gets runtime and who doesn't when there are periods of contention. Now, obviously, we try and heap manage, so there aren't the contention is very rare. And that's the function of kind of placement in the large, is to make the placement or make the optimization in the small problem tractable. This is very multidimensional. There are all kinds of bottlenecks on hardware. I think people think about CPU and think about memory, but as systems folks like yourselves know that there are all kinds of other things that are going on there, right? Like there's space in the CPU cache hierarchy. There's memory bandwidth. There's all kinds of limited other limited resources like networking, storage, and so on. There are things like the page cache of the host OS, there are actually just lots and lots and lots of these resources, and typically systems, because they need to actually have a tractable problem to solve, consider fairly few of them. And so one of the interesting problems is really picking out the ones that we think are most important to performance, and trying to ignore the signals that are just noise or just not particularly relevant to performance. So it's this big multi-dimensional kind of optimization problem. And we've got some very interesting work going on optimizing that using approximation algorithms for linear programming. And then obviously, like all things cloud, there's really interesting problems around pricing, around economic incentives, and the way that we price products to offer our customers a great experience and great value, and give internal and external customers incentives to help us drive up hardware utilization. And so that's an even kind of bigger kind of meta optimization problem. In the development phase, code changes rather frequently. When a customer's code is changed slightly, does Firecracker require a new cold initialization step? The short answer is yes, and the reason for that is that we can't reason about, in general, what that small code change is going to do. As a lot of folks will know, there are formal techniques. There are all kinds of code analysis techniques to look at a piece of code and say, this will interact in this way. But those tend to be fairly limited in scope. They need a bunch of help. And so this problem of looking at an arbitrary code change submitted by somebody else in context of a large code base, and knowing whether it should be cold started or not, is not something that we have solved. And so we replace micro VMs on every code change. And we think that is the right thing to do. It also means that the system is very easy to understand. And so if you're thinking, how do I get new micro VMs? Well, you can make a code change. Is there any optimization scheme to reduce the initialization time with updated customer code? Yeah, you see, that's a really interesting question. And I think maybe as we get into the timeline stuff, I'll talk about this a little bit more. But there are fairly easy ways, for example, in a language like Java, to say, here is the stuff that runs in initialization, right? It's the static code. It's the stuff that happens at class load and startup time. It's Java agents. It's command line variables to the JVM and so on. And each programming language has similar things. VM languages more than native languages. And that is one example of something we can reason about and say, well, we can reuse initialization steps. And again, like to the topic I talked about in the talk, virtual machine snapshots at the virtualization level rather than at the JVM level is one very powerful tool for doing those kinds of optimizations. Am I going too fast or too slow here? Okay. In the presentation, you see the bar with an approximation of the overhead to create, download, and snap. My understanding is the network will become faster as better network links are produced. Yeah, I mean, I think that's pretty safe. I don't know if you all saw the announcement this week. We launched an instance type with 400 gigabit networking, and that's been this trend. As you know, well understood, both just faster and faster and faster Ethernet, but also, as the question says, new technologies such as RDMA, kernel bypass, all of the stuff that lets us push networks harder. And so, yeah, that download step, the just moving data around the network gets faster. That's always balanced, as we know, by software getting bigger, and software ecosystems getting bigger, ML models, data sets getting bigger over time. And so this isn't really different from what has been the story of kind of systems for so much of so much of the history of computing. But yes, download just does get easier and faster over time as storage gets faster. So the two major bottlenecks will be create and init. I think that's true. How can you improve these steps to avoid latencies and get closer to millisecond times? I mean, this is the core of what I was talking about in the, with one tool there, and we've got others on the go too, but one tool there being vert snapshots, where we can avoid that create and unwrap a fully booted kernel, although the create isn't on the blocking latency path. And then we can, do init and then reuse that snapshot multiple times. So we can either do that ahead of time or we can do it once and then make a set of clones. And as I go through some of these other questions, there's some interesting trade-offs there. There's a whole bunch of other stuff to do, but these are the kinds of things that need to be done. And I think there's language level stuff, there's runtime level stuff, there's library level stuff, and then there's kind of virtualization and operating system level stuff. And if we want to give people really fast scaling for wide varieties of workloads and sort of compatible with stuff from the past. And, I think there's innovation needed and we're working on stuff at every one of those levels. It seems like you're implementing mechanisms to cope with challenges for snapshotting at the OS level. I'm curious if there's a requirement to address challenges at this level, or whether you could get some help from a runtime, like a custom JVM. My understanding is that serverless functions in managed languages would require a runtime you provide, so the runtime could help. Yes and no on the understanding. Platforms like Lambda do provide a set of built-in runtimes. We also allow you to bring your own runtime. And so, our customers can run, for example, Java on our runtime, or they can run, bring their own JVM. And, different people have different choices there. In general, our runtimes, they're up-to-date versions of Amazon Corretto, which is our OpenJDK distribution, and so most people end up choosing that. So I think the basic premise of the question is just right. Like, hey, what can we do at the VM level to accelerate this stuff? And the answer is actually quite a lot. In the particular case of Java, there are some constraints around the Java language type specification about what time things will happen and the order that things like pass loading and static code execution will happen in. And so if there are heavy frameworks, if there are heavy chunks of static code that you need to give to the JDK, there's only so much you can do that's better than that, short of snapshotting. So there's some some things we can invest in with stuff like the JDK. I think Java in general has done a really good job over the last couple of years in getting slimmer at startup time. I think startup times are quite strongly down over from Java 6 down to 8 and 11. Or at least that's what I remember of the numbers. But a lot of the challenge here isn't in the Java VM itself that starts up rather quickly these days. A lot of the challenge is, folks want to use frameworks, they want to use application servers, and so on. And so these things take a while to start up. So if you pick, you pick Spring Boot or one of these other fairly heavy Java frameworks, there's just a lot of code that runs at startup time. And so a lot of the investment that might happen here is investment in things like, frameworks. There's also a little bit of a culture change there, and that is because I think historically the Java framework community didn't really worry about startup time. Totally rational, because a lot of traditional architectures are just not particularly sensitive to it. And so it's just not something that people are used to paying attention to or used to spending time optimizing and so on. I think over time, as we say to people, we value this, and over time, as folks adopt serverless and adoption grows, I think that's going to change. Software ends up where the people working on it value it ending up, and so startup time is just one thing that didn't used to be a big deal and is now more and more of something that people care about. Have you considered addressing cold start latency by exploiting snapshotting of shared components across different functions? I imagine the functions running in similar environments could potentially benefit from a cold start that's semi-warm from an image. Yeah, absolutely. There are a whole bunch of interesting trade-offs here. There's some kind of obvious ones like address-based layout randomization, ASLR, which might require you to start new processes. I think there's other stuff we can do there too. But in specific cases like the JVM, people want to inject stuff in environment variables and in Java command line options and in Java agents that current versions of Java assume are there at startup time. And so there's a little bit of reshuffling around that is needed in the internals of the JDK to be able to late bind a lot of that stuff. I'm not a deep JDK expert by any means, but I think there's some interesting and useful stuff we can do there too. And obviously, the later you get the workload-specific pieces, the more you can do the common work earlier and earlier, and the more of the common work you can do. And again, this is something that the OpenJDK doesn't support because there was really just no demand for it until, or not no demand, but not as much demand for it until fairly recently, as serverless has become, more and more popular. I noticed during the talk that most of the topics discussed were useful to serverless and function as a service, but not specific to serverless. Yeah, I think that's accurate. Has there been much focus on serverless specific solutions to these and similar problems? Yeah, and I think a lot of that depends on what your definition of serverless is. And we as industry and in the research community, there are multiple definitions that people use. I think that's a good and healthy thing for an area that is honestly this new. For example, one of the things that we really value in Lambda is compatibility with existing code. We want to be able to say to our customers, bring this code you have. You've been working on it for a long time. It's very valuable to you, and our platform will be compatible with that. And so that kind of thinking and that kind of requirement means that there is it restricts how much kind of serverless specific stuff we can do. And the reason we value that so highly is, code is valuable, and especially for enterprises. A lot of people have spent decades encoding their business logic into their code bases, and for some of them, those code bases is the only copy of their business logic, and so the idea of go off and re-implement or rewrite this to adopt serverless is just not going to fly, and it's not going to fly for really good, really understandable reasons. I think you can make different sets of trade-offs. You can offer different serverless products with different sets of trade-offs. I think those are equally valuable or equally valid ideas. And as you go up the stack, and as you can throw out more and more of the legacy, that's a bit rude, but the historical stuff, you can do more and more serverless specific optimization stuff. Is there an attempt to leverage specific assumptions that might be true in serverless but not elsewhere? Yes, absolutely. So having said that, we do, having said how much we care about compatibility, there are Lambda-like specific things that we can take advantage of. There's the time limitedness of invokes, right? Like we know that invokes are limited to a certain amount of time. Today, that's 15 minutes. And that bounds, that goes into the placement and load balancing decisions. It goes into the how much of a mistake can you make if you commit a resource. It means that we don't have to worry too much about these sort of slow growth of resources and things that happen in OSs over time. Like you boot up a Linux box and you work with it, and you'll just see that its memory usage grows over time as it gathers caches and buffers and things. And that's good, right? Like this is a good thing that kernels do that. But when they are time limited to a certain period of time, we can limit how much that is. And so that matters less. I think the strong isolation that we have with things like Firecracker helps. It gives us a lot of optimization opportunities compared to some other approaches in the space, because we can just make assumptions about particular things that are true about one side of that isolation boundary versus the others. And the other thing that really helps in serverless is knowing when the machine is quiescent. If you just have a random server with a bunch of software on it, the average Linux box with a whole lot of processes and things is never really quiescent. It's never actually quiet. And in Lambda type serverless, at least, because there's a stream of requests coming in, they come into a box, they land there, they start, they complete. It's like a unit of time. And then once a request is complete, we know that the machine is, to the customer's perspective, quiescent, and so we can use that as an opportunity to do things like take the snapshot, right? We also know init time versus runtime and so on, and that's also something that's not quite as well defined in the broad general world of operating systems. I'm also interested, if the folks who asked this question are around for the live Q&A, I'm also interested in just hearing more about about what you have in mind here. Super interesting stuff. Alongside trying to shorten boot up and deployment times, we're also looking at specialization inside the VM on the Linux kernel level. We are. I don't really have plans I can talk about specifically there. I think once again, compatibility is important. I think even Linux, if you just compile out a bunch of the stuff, is actually quite small, and so the fixed overhead is relatively little, but there is space for overhead optimization, and also for optimization in reducing size of things like attack boundaries and attack surfaces for security purposes and so on. And so I think there's a great deal of opportunity there. Just don't have plans I can really talk about concretely yet. Since the VM will run a single workload, does that loosen the security and isolation restrictions inside the VM? And does that result in optimizations one cannot use in normal secure general purpose OS settings? This is a line of thinking that a lot of unikernel and library OS projects have really pulled on. I think it's a really, really, good, smart line of thinking. For some kinds of reasons. I think there's some challenges here too. I think if you look at the code that is running inside serverless, it's still, some of these are still big code bases. Some of these code bases, the things like attack mitigation, exploit mitigations, and permissions, sort of local permissions lockdowns and things to make it harder to persist on a inside their micro VM, obviously, are still really meaningful controls, and so you don't want to just blow everything wide open necessarily. You might want to give the option to blow everything wide open. And so there's an interesting trade-off there, right? Like of, how much power you give to a process and how much you allow that process to kind of lock itself down. And there's not really one just super right answer to that. So yes, I think there are interesting optimizations here. I think there's a compatibility trade-off as usual. And I'm excited about the innovation and thinking that's going on there. But again, just from a pure overhead perspective, it's not necessarily for Lambda-like workloads a big economic deal. Do you think it will ever be possible in the future to simultaneously both use serverless and kernel bypass RDMA networking abstractions? And the question says they're concerned that today's serverless abstractions may be incompatible with these new networking abstractions, and research has shown that kernel bypass and RDMA networking are important for providing low tail latency. Yeah, this is a fascinating question. I don't think there are fundamental limitations. I think there is work to be done. I think there's research to be done. I think there is definitely work to be done on the hardware side. I think there are interesting trade-offs between density and speed of sort of control plane change that serverless allows, and number of workloads on a box, and how quickly those workloads come and go, and how quickly we want to be able to schedule those workloads in and out. I think that stuff today has a bit of an impedance mismatch with a lot of the options that are available for things like kernel bypass. But I don't think those are fundamental truths. Like, I think they're just implementation challenges. I love this direction, right? Like the thing that I think we need to be focusing on is, we don't want compromises, right? Like, we don't want to be in a position where we say, hey, adopt serverless, but it's going to be slow, or you're going to give up performance, or you're going to give up network performance. Like, we don't want any of those things. We want a world where the serverless model is just applicable to everything, and that's what we're working towards. And I think there's some really interesting research problems, open research problems there. And then the security aspects of that are really fun too. So yeah, great stuff. Would love to hear more about what you're thinking here. Is Amazon interested in formal methods? How is system correctness handled? Is there any team applying such formal methods? Yes, we have teams working on formal methods. Both teams dedicated to formal methods, and a whole lot of engineers in our service teams who use formal methods in their day jobs. So if you go over to Amazon Science, there's a security, the www.amazonscience.com, Amazon.science. That's our publication site. There's a security category, and you can see a whole lot of the stuff that we've published in formal methods, looking at all kinds of aspects of that problem. It's something that we think is just very important to continuing to raise the bar of security in the cloud, and security is always our top priority, and formal methods are a powerful tool there. Correctness is also a priority. It drives availability, it drives durability, and so this is an area that we are investing deeply. We're building tools, we're working with the research community. I was also a co-author about 5 years ago on a paper called how Amazon Web Services uses TLA Plus, and that goes into some specifics of a whole bunch of our services and how we applied TLA Plus to distributed protocol correctness problems, and that's a tool I use still quite frequently. And then more recently, I've been checking out a tool called P, which I'm pretty excited about. So cool stuff going on in that world. Are there fundamental challenges in incorporating the snapshot restoration ideas proposed by Catalyzer into Firecracker? No, I don't think there are fundamental challenges. I'm not going to compare gvisor and Firecracker. Other than to say, I think we made our choices for reasons that I believe are important and valid. But I don't think that there's any reason that the Firecracker model can't achieve everything and more that the gvisor model can in this direction. But it's I really enjoyed the Catalyzer paper. I think there's a whole bunch of cool stuff in there, and so great to be thinking this way. How do you implement security in the service? I'm actually doing a talk in a couple of weeks around our reInvent conference that just talking about the security boundary in pretty great detail, and some upcoming work that we've done in this space. And so we can distribute the link to that. That is SVS 404 on the reInvent catalog if you're interested in that. So I won't go into that now. Also, our NSDI paper about Firecracker talks quite a lot about the security trade-offs and how important they are to us, and what we do there. It's a fun field. It's been really exciting to dive into that and work on it. Can you comment on the recently announced Nitro Enclave? No, I can't really. I just don't know enough about that. I think it's cool. I've played with it a bit. I think it's exciting, but I don't have a whole lot that I can say about that that we haven't talked about. What's the biggest lesson learned developing this with the open source community? I think we're just thrilled, developing with the open source community. We're thrilled by how many people have gotten excited about Firecracker and about Rust VMM. And so I think one big lesson is that it's just been successful and nice. I think the biggest takeaway for me has been that we've been really lucky to have some folks in Amazon and some folks out in the open source community who are just really passionate about building a strong, inclusive, welcoming, friendly, kind community around Firecracker and Rust VMM. And I think that kind of community building work is just extremely important. I think it's something that technical folks sometimes undervalue, and I think it's a place that when I get involved in future open source projects, I'm going to be paying more attention to maybe than I did in the past. So that's really been a lesson learned for me, and so just very happy with those efforts and and some of the good feedback we've had from folks who've gone into that community and have worked with our people and have been very happy with that. So that just makes me it makes me happy when I hear that stuff. Okay, so live Q&A via the chat box, or you can join over video. I think we have about 20 minutes. Whether it's specifics about what I've talked about so far, or if there are other things you would like to ask, now's your moment.
Hey, Mark. It's Darby. For everyone who wasn't here before, I'm the Amazon Conferences Community Manager. I'll be asking you the questions from the chat box. You had about 6 questions during your presentation. Again, yeah, if you guys want to join on video to ask a question, or if you want to keep just dropping in the chat box, whichever you're most comfortable with. But the first question is, can I run Firecracker on a number of virtual processor cores in RAM much larger than the current limits of Lambda, for example, to serve deep learning models?
Yes, is the short answer to that. The longer answer is kind of. So Firecracker scales really nicely over a number of cores and an amount of RAM. I don't know what exactly we've tested up to there. I think the challenges there right now is I/O performance. We touch on this in the paper. We've invested since we've written the paper in improvements there. We're making progress, but the I/O emulation in Firecracker is still quite single purpose for the needs of serverless, and so if you want to do really big stuff with it, I think there's going to be investments that need to be made in I/O performance and I/O scalability compared to where Firecracker is right now. I don't think that's a fundamental thing about the model, but it is an indication of one of the things that we did with Firecracker for Lambda and for serverless was really specialize it for the needs of those use cases, and so I/O performance is something that we got up to a bar that we thought was great for the customers of those services, and are continuing to invest in, but it's still behind what you would get with something like well set up QEMU.
Thanks, Mark. The next person says that they have recently been doing a lot of research in serverless, including a measurement study on AWS Lambda itself. And they observed one interesting phenomena, which was extremely high CPU steal times, 50% plus, as well as placement gaming opportunities. Can you talk a bit about scheduling for serverless and what the AWS Lambda approach is?
That's interesting. I'm actually surprised to hear that you're seeing that, and so without looking at the results in detail, I don't have a whole lot to say about that. But that sounds unexpected to me. So, if you're willing to share your results, I'd like to see them and share them with the team and have some folks dive in on that. As you know, there's multiple things that can drive steal time, but we shouldn't be, or you shouldn't be observing large amounts of CPU contention.
And the next question, could you elaborate a little more on the scheduling challenges within a single machine? Is it common to have thousands of dormant micro VMs?
Yeah, we talk about this in the paper a bit. So we have hundreds to thousands of workloads on a machine. That typical. These are fairly typical server class machines. For example, if you picked an EC2 M5 metal, right, like 48 cores, 360 whatever gigs of RAM. And so there are a lot of dormant workloads on a box at any given time, and only as many active workloads as we can run without blowing in the latency and CPU consumption budget. And so the scheduling problem around that is very interesting. I don't have any specifics I can share about what we're doing there right now, but it is, yeah, it's an interesting challenge. And maybe one thing I can mention is that some of the work we've done is looking at workloads that are correlated in time, and at the higher level, placing workloads that are correlated in time spread through the fleet to try and drive down the peak to average ratio in CPU demand, because as systems folks know, but I think a lot of people don't think about CPU demand from processors is just extremely spiky. There tend to be spikes on particular boundaries, like the 1 minute boundary, the 1 second boundary, the 1 hour boundary at midnight, and so on. And those are completely driven by human foibles, right? Like we want something to happen once a day, so we're going to do it at 0.00000 UTC, and computers don't care, but we care, and because we're human, we've built a lot of these spikes into systems around particular times, and so that's one particular scheduling challenge, is looking for things that we think are going to spike at particular times, and spreading them out in the fleet to make the micro job of scheduling easier on the box, where it's just more constrained, right? You have fewer options, fewer degrees of freedom.
Great, thanks. And the next question is, do you have any plans on offering analytics optimized AWS Lambda, maybe even some type of serverless function types with accelerators?
Yeah, accelerators is a really interesting one. I can't share specific things there, but I think it's safe to say that the general industry trend is that accelerators are going to become increasingly important. If you go back to, I think was Patterson and Hennessy's Turing Award presentation a couple of years ago, talking about the trends in the industry that are driving that. That really resonated with me. I think a lot of that stuff is true, so nothing specific I can share about our plans there, but I think the directional thing is yes, that is an area that we're investing in.
All right, the next question is 2-in-1. Can you share whether the micro VMs for Lambda run Linux? Would it make sense and be possible to run Lambda on unikernel-based micro VMs?
Yeah, Lambda's unikernels run Linux. They run a slight variant of Amazon Linux too, both the host and the guest. We compile a bunch of stuff out of the kernel. There's actually, in the Firecracker repository, there's a kernel config for an example of a kernel with a bunch of the stuff compiled out of it. Like, Firecracker doesn't even support PCI, so you can take out a whole lot of the kernel and end up with a kernel that's quite slim. And that's what we do. We don't run exactly that config, but we run a somewhat similar one. Can we run unikernels? That's a great question. So there are unikernels that work on Firecracker. OSV works on Firecracker. I think some people have ported some other ones. Fantastic startup times, very low overhead, exciting stuff. I think in context of Lambda and Fargate, it's hard to give the kind of compatibility promise that we want to give without actually running the Linux kernel itself. Trying to be both compatible and bug compatible with Linux with a de novo implementation is hard. And so I think there's a huge amount of very welcome interest in unikernels. I think it is an important direction for lightweight virtualization, but that's not something that we're doing with Lambda yet.
And the last question is another 2-in-1. The first is, would AWS publish a study of the production serverless workload traces like what Azure is doing? If not, do you see any differences on the workload characteristics compared to the Azure study?
We do, and I have spoken to a lot of people in the community about the value that that researchers get out of workload traces and data from industry. I think that is something that I think about it is something I just think about a lot. We have some real important things to balance with that, though. One of them is the security and privacy of our customers is our top concern always. And so, data sets that are rich enough to be useful, but also anonymized enough to really protect that privacy and be completely respectful of our customers' expectations in using AWS. That's a real tricky thing to do. And so I guess the big answer to this is maybe. And we've got a lot of work to get there. But I think in general, our overriding concern is the security and privacy of our customers and of their businesses. And I don't want to be in a position where people can look at a workload trace and infer things about who a customer is, what their business is, how many sales they're doing. That's just stuff that customers have entrusted to us, and we just can't share. So I see the value in it. There are a lot of challenges there. As for the second part, I really enjoyed the paper from the Microsoft folks. I thought that analysis was super interesting. And I think the data sets, I forget exactly how much they published, but I think there's some real valuable stuff there. There's nothing there that jumps out to me as being particularly different. I think maybe one potentially interesting thing there. Yeah, actually, there's nothing in particular that I looked at and I was like, wow, this is surprising compared to what we see. But there are certainly differences. Those differences driven by scale, by geography, by customer mix, by the technical design of our different solutions. So there are important differences, especially in things around like seasonality and peak to average ratio and noise and so on. Yeah, sorry, I can't say a whole lot about that. So a little bit of waffling there.
Thanks, Mark. Those were all of the questions that were asked in the chat box. So I would welcome any last questions. We still have a few more minutes in this office hours session. Yeah, feel free to join on video, drop them in the chat box. If not, you guys can send them to the email osdi2020@amazon.com. I'll drop it in the chat box again if you want to connect afterwards. But we'll be on for a few more minutes if you have any final questions. One question, where do we find the recording? You can find it on our YouTube channel, but I will drop it in here now. All right, Mark, one more question. How did you make the switch from electrical engineering to cloud?
Yeah, that's actually really a little bit unintentionally. So, I was at the University of Cape Town. I was working on radar. There, weren't a lot of opportunities in civil radar, and I wasn't enthused about working in, just for my own personal reasons, working in public sector or military. And so I was looking around for something else. And I just happened to be chatting to some folks at out one night who were working at this new office on this new thing for Amazon. And a couple of years later, I thought about them when I was looking for a job, and I gave them a call. And they were the team that was building EC2 at the time in Cape Town, and had just launched EC2. And it seemed like a real interesting thing. I was doing simulation for my PhD, and I was constantly frustrated by, just trying to get compute resources, and the idea of just being able to spin stuff up on demand and pay by the minute. And it just seemed so magical to me, that I was, wanted to get in on that. I didn't know how it would work out, but it, turned out to be something that I, really, really enjoyed doing.
Awesome. One more question. Does the AWS Lambda team intend to make more research publicly available, or is Firecracker it?
Yeah, I think we're going to keep publishing. I think we're going to keep open sourcing stuff. I don't have specifics to share, but I think we're, as AWS, investing very deeply in this area, in virtualization, in serverless, in whether it's Firecracker and the Nitro system and so on. We want to keep telling people about it. We want to keep contributing back to the larger community. We want to build communities around this stuff. We want to look at things like the container ecosystem and see some opportunities for raising the bar with security there. And so I think there's a great deal to be done. We're going to keep doing it. And so, yeah, more just watch the space. I'm sure you're going to hear more from us.
What is your approach to following research and learning on the side?
Yeah, that's evolved through my career. I think I've always found reading research to be something that I enjoy, just as a kind of intellectual thing to do. And so I kind of got into the habit of it when I was in grad school, and I continued to sort of get into systems research, mostly as I need to learn about X. I'm in this whole new space, and I got into that, and when I was working on storage, reading a lot about storage systems and failure statistics and point models and so on. That evolved over time into building strategies to keep up to date. I think for me, that is following conferences like OSDI and NSDI and SOSP and Eurosys earlier this year. I tend to read the abstract of every paper at those conferences. And then I follow a bunch of researchers on Twitter, and when they tweet about interesting stuff, I read their stuff and check out their papers. So right now, my paper reading backlog is several thousand deep, and is growing faster than I'm reading. But it's something that I found very fulfilling, and it's something that I really encourage people to do, because I think, for working engineers and for folks in industry, keeping up with research and keeping up with the work of the rest of the industry is just so so important, because ultimately, we're not an island, and no, neither is anyone else, and we have so much we can learn from each other. So it's something that I make time out of my day and out of my week to do.
We have about 2 minutes left. We have time for about one more question. Are there any final looming questions you guys have. All right. Looks like there are no more questions. Again, please feel free to connect with us afterwards. I will drop the email in one more time in the chat box. Mark, thank you for answering all of these questions and for giving the presentation. Thank you to everyone for attending this session.
Thank you for moderating and keeping us on track here. I've really enjoyed everybody's questions. It's been been super thought provoking going through this stuff. So as Darby said, do get in touch.
Thanks, everybody. Have a good rest of your night.
You're